All right. So, any questions here so far?
No, sir.
All right. Now, what should we know about acids? That's the question we should I try to answer here. All right. Does anybody know what an acid is? Yeah, so nobody knows what an acid is. So let's bring up the information about what acids are. So in order to find out what acids are, we have to go all the way back to, I'm gonna go in for the syllabus here. It's gonna be, let's see what's going on here. All right here. Well, let's after this, it's gonna be acid, base, and salt. All right, look at that. Everybody see the screen? It's gonna zoom in.
Yes, sir.
Yeah. So yeah, acid, base, and salt. We have to go first thing. We have to go define acid. We have to define. We define acid, base, and then salt. All right. So let's go at it now. All right. Basically, um, long story short here, acids have three definitions. All right. So that's the first thing. Acids may be defined as, it may be defined as, all right, check this out now. Well, all right. So the most basic definition is that an acid is a substance that gives up hydrogen, right, when it is dissolved in something that contains water. That's pretty much it. A substance that gives up hydrogen ions when it reacts with water. That's it. All right. So acids are all about hydrogen. Okay. So an acid. All right. Let's see. So basically, a compound um, that forms. Yeah, I'm gonna give you this one. I mean, I'm gonna kill you with the three definition. I'll give you one. Very quick, because when you learn three, very technical. So a compound that forms, all right, that forms hydrogen. Yeah, yeah, yeah. Yeah. So we're gonna work with this one. All right. So example here, guys. So example of acids where hydrochloric acid is the most common one. Um, all right. And then we have sulfuric acid. And we also have nitric acid. But then we're going to use this. All right. Everybody see the definition here?
Yes, sir.
All right. So all right, so let's go. All right. So once you have that definition now, and all right, so that's one definition, but I'm going to introduce it to this now. You're saying I don't run this fast. All right. So for the purpose of the experiment, why is so huge? Let's condense this because this is sort of technical here. I'm just going to condense it right here. All right. Yeah, let's work with that. All right. So, all right, guys. So now we have different types of acid. We have, right, what I'm looking for here is strong and weak acid. So we need examples of strong acid and weak acid. And then that's where we're going to find out about vitamin C, because vitamin C is in one of those categories. All right. And notice that the definition doesn't contain anything about burning or how it behaves. It's just a substance that gives up hydrogen ions. When the acid is reacting, however, when hydrogen ions are given off, it changes into hydrogen gas, which bubbles. So that's what causes fizzing in acids. All right. So when you look at strong acid, because those are the two categories of acid, strong acid versus weak acid. All right. So see if I can find a list of those here. All right, well, I'm seeing a list here of quite a few here. This should be interesting. All right, copy this one. All right, so let's just condense this and we can make this simple. All right, body seeing this should be, and let's get this out of the way. All right, so we could even cut out some of this acid here strong. All right, so everybody should be seeing this, right? So you're seeing the different examples of strong and weak acid.
Yes, sir.
Right. So I want to see if there's a definition, a nice definition for it. But if I don't see one else, when you have to give you. All right, not seeing a proper definition at all. Well, okay. I think that's it. Thing about acids that there are three theories, and at CXC level they don't want us to tell you too much about those theories. But the strong acids now, we're looking at hydrochloric acid, nitric acid. So far as they don't have sulfuric acid here, but it's one of those. Hydroiodic acid, perchloric acid, chloric acid. These are not so common. Definitely not so common. But then weak acids, well, nitrous acid, which is different from nitric acid. That's different. Most common acid here, methanoic acid. Yeah, this is actually in ants. This is actually ants acid, you know. This is ants bite, actually. That's the part of the ants bite that stings, methanoic acid. So when the ants bite you, it releases methanoic acid in your skin or wherever it bite. And that's what causes the irritation. And anybody get any rash when ants bite them? Jonathan, Kimberly, or Rachel?
Sir, the area will scratch me, so I guess yes.
I get a scratch. All right. Jonathan, you there?
Yes, sir.
Oh man, you know the day, man. I sleep, man. Wake up.
No, sir, man, I sleep, sir.
You see, Kimberly, don't even sound like him sleeping.
Yes, sir.
Yeah, man. I mean, a girl can't see it. A girl know when man is sleeping, man. So you can't tell time you sleep out. All
No,
right.
sir, me not sleep, sir, me not sleep.
Why we have fast then none?
That's it. All right, guys. All right. So at least up to this point, guys, you should be able to tell me example of strong and weak acids. But the definition though is that a strong acid is an acid that can give off hydrogen ions easily. All right. Strong acids. I want to define it, but I don't want to use words that you don't understand. And that's very difficult for chemistry because chemistry people tend to chat enough. So let me just simplify it. A strong acid is an acid that easily produces hydrogen ions. Okay, that's basically it. So easily produces hydrogen ions. But you see that?
Yes, sir.
All right. And then weak acid does not easily. Yeah. So yeah, there you go. What are your strong acids? Okay, I like this list. So yeah, now you have that definition there. I think this one would be better. Let's see. Internet kind of going. Oh, okay. You guys can hear me?
Yes, sir.
Yes, sir.
Oh, because I get a message at my internet, something happened to it. All right. Well, here it is now, guys. Well, according to this, say we can identify strong and weak acids. So this list is better. The ones that you're expected to know are number 5, number 6, and the second one. All right, rest of them can't forget about them for CXE purposes. All right, and of course these weak acids you're going to need to know this one. So acetic acid is actually what's used in vinegar. All right, formic acid is the same thing as methanoic acid. This is the ants acid. The ants bite. So it's methanoic acid. Methanoic. Let's correct that word here. Methanoic. All right, so that's important. This is the ants bite. So if you can remember the ants bite, you certainly can remember this. All right, we also have think of the rest of them. Well, this is hydrogen sulfide. So yeah, and they will ask about the occasionally, and of course this one is important. This is actually carbonic acid. Why did I put hydrogen sulfuric here? It's sulfide. All right, this is actually a gas though. I'm surprised they put it there. Some hydrogen sulfide is a gas. This one, H2CO3, this is actually carbonic acid. So we're going to realize that some of these acids have different names. All right, the vinegar is also another name for acetic acid. All right, methanoic acid is also known as formic acid. And also then, all right, and then we have here H2, H2S, which is hydrogen sulfide. Well, that doesn't have any other name. Carbonic acid is what is used in soda. So used in soft drink. So the acid in soft drink is actually carbonic acid, which is a weak acid. It couldn't be too strong for that purpose, really. All right, so that's it. Any questions here, guys?
Sir, like for the nitric acid, what would happen if it came in contact with the skin?
That's a good question. Nitric acid would out of all of these acids I'm seeing here would do the most damage. It's going to definitely going to react with the skin. Again, all acids do is just give up hydrogen ions, so it's just going to it's going to remove hydrogen ions from your skin, and then the process when you remove hydrogen ions, it's called oxidation, and so it definitely oxidizes your skin. And then if you check it out, if you check the definition for oxidation in biology, it's related to aging. That's what really aging is. Aging is oxidation of the body with time. So the nitric acid now would just accelerate that and damage your skin. Certainly leave a hole in your skin, and I doubt that it is irreparable without plastic surgery. So
Okay, so you said the nitric acid is the most dangerous acid there.
no, to your skin or to like the human body.
Okay.
Yeah. So maybe in other situations it might not be the most dangerous, but definitely nitric acid is something that you can't play with. Actually, this is the only acid here that can dissolve gold or attack precious metals, which makes it strong in that regard. So this acid is so strong that it can react with things that don't react. So like gold and platinum, those substances don't react. So once you can find an acid that can react with it, it is telling you that the acid is very strong. Because of that, the other name for nitric acid is actually this one.
Sir, we have some sort of something to contain that the acid there, sir.
Very good. Yeah. Certainly it has to be stored in a special type of glass container, and it has to be sealed. And even you can't seal it with plastic because it's going to react with the plastic. So it's a difficult acid to contain. As a matter of fact, if you're gonna buy this acid, the transportation cost alone is very high. So
Sir, why doesn't it react with the glass? Is there something in it that prevents that?
well, yeah, glass no glass is a fairly durable substance, and yes, there's something in the glass that prevents it. A glass is actually a mixture of three things. Glass is actually made from sand, soda, and lime. Now, the soda we're talking about here is sodium. Yeah, it's actually sodium is a sodium-based compound. In case it will be sodium carbonate, I believe. So that's so those the things that make up glass make it very resistant to attack from chemicals. So yeah, different types of glass too. So that's the point. So no, the glass container that you're going to store, it can't that if it was made from sand, soda and limestone, that is, I think nitric acid would react with that. So they'll have to make a special type of glass. The other type of glass they have is Pyrex, which is what they use for the glass that you can put on fire and cook with. That glass could hold nitric acid. The special type of glass that. So you have to store it carefully, guys. And we say it's glass container. And I think I had some at IPAS, and I think it well, no, I actually know that it eat off the cover that I had on it. It was there for a couple years, and the cover just part of the cover was gone. So it react with the cover over time. It's an acid that you can't really keep for too long. All right. And the only way you can store it and make it stay put is you have to really dilute it. So, and also it's something that we could make, something that can be made in the lab. It can be made. I know how to make it, but I never try making it before. But it's sort of dangerous because you need goggles for it. All right. So yeah, that's nitric acid here. Very dangerous acid. Aquafortis is the ancient name for it. When they discovered it, they spoke Latin in those days. So aquafortis translates to English to mean strong water. That's the literal, that's the translation, strong water. So yeah, so what they realize now is that if you have like gold and so now and you drop it in there, the gold will just dissolve in it, you know. So yeah, they call it strong water. It look like water, but it's, trust me, it's not water. So there you go. All right. So that's pretty much yeah, the discussion here on acids. You have any more questions? So you're learning today that nitric acid is something not to play with, you know. Next class we probably can go into how we can make the various acids, which most of them are fairly easy to make. All right. Certainly though, it's the trick to making a good acid though, you need cold water, you need ice, because ice, what does ice actually reduces the reactivity of the acid. So yeah, that's how it works. So keep it cool. That's a secret to storing acid. All right. That's why, like with soft drink, for example, that's why soft drink is drunk. You best you drink it cool, you know. When it cool, it have more acid in there, you know, and then you know how that work already. When you have the cold drinks and you shake up the back, what happen? And what happen when you open it? Well, I never do that. Anyway, all right. So that's it, guys. So, any more questions? Yeah, let's take the register here.